Friends, let's have a look at this one about the term concentration. Now, this is generally we look at it in the context of this allegation, because whatever we have talked about so far in the earlier models, the earlier kind of the questions, we have seen the cases of this profit percentage, we have seen the cases of usual this average marks or the average price, etc. Now, when we are talking about the term, you will come across with situation like there is a milk of, let's say, maybe concentration 20%, it is mixed with another milk of concentration maybe 40%. The resultant solution has a concentration of maybe 35% or maybe 32%. In what ratio the two quantities have been mixed? That becomes very easy to really tackle using this part, but some additional bits over here related to the term concentration. Generally, you will come across with parameters like, okay, the quantity of milk, let's represent this as by variable maybe M, the quantity of, let's say, maybe water, milk water scenario, represented by the variable, let's say maybe W, the total quantity, which is milk plus water, this is, let's say, maybe T, the concentration of milk, Cm, and this is generally we represent it in terms of percentage, concentration of milk or maybe concentration of water. Now, a very simple situation, let's say there are 60 liters of milk and I mix it in 40 liters of water. Total quantity is 100 liters. Concentration of milk, we say that, look, this is 60% and concentration of water is 40%. So eventually what happened? Why did we say 60%? Simply speaking, 60 by this 100 here. The idea is the concentration is defined as the quantity of that particular liquid out of the total quantity. So we can say the concentration of milk is the quantity of milk by total, not the quantity of water, by total, multiplied by 100. So that's the key idea with respect to when we say concentration of milk, or even for that matter concentration of water. Now, how will this understanding really help us? But before that, if we take up, let's say, a situation like this, if I have maybe 20 here, let's say some number which is, this is 20, and this number is given to us, which is maybe, let's say, 80%. I need to find out what could be the quantity of water, what could be the total quantity, or what could be the water concentration. Point number one, which makes it very clear here, when we are looking at the water concentration and the milk concentration, the sum total will always be equal to 100. So if it is 80%, I can say that this number must be 20%. Now, how do we obtain this total quantity of water and total quantity which is there? Multiple methods are there. This 20, this part, this milk is given to us. This 20 is 80% of what? 80% of some total quantity. So we can say that this 20 is 80%, 80 by 100 multiplied by this total. So that's a standard thumb rule which we apply in terms of arriving at the answer. Thereafter, this makes it as total, which is equal to, simplifying that, 4 by 100 by 25, this is 25 liters. So there are altogether 25 liters, and from there 25 minus 20, that makes it as 5 liters here. Or the moment we obtain these numbers, this total clearly could be any number, may or may not be 100. So these two examples just clearly illustrate what we have the basic idea related to the understanding of the term, the concentration of milk, or for that matter, the concentration of water. And then next time, out of these three terms, any two terms which are given to us, which we should be in a position to obtain the third parameter. So just now we saw that, for example, if the concentration is given and the milk quantity is, let's say, which is given to us, we can find out the total quantity. In the same way, if you are given maybe, let's say, the total quantity and the concentration, we can find out the milk quantity. So there are three different possibilities: concentration, total given, concentration, milk given, or milk and total given. So thereby we can find out the third parameter. So with this basic understanding, friends, let us look at some of the very, very important set of the questions which come across on a frequent basis as far as the idea involving the concentration and the allegation is concerned. So let's go ahead and take up those questions. Now let's look at this question built around this idea of concentration, allegation, mixture and all packed together. And what it says that there is an initial ratio of mixture or a solution of milk and water in the ratio of 3:1. To this solution, 40 liters of water is added. The new ratio of milk and water is 2:3. So what is the initial total quantity? A lot of methods are there, 3 to 4 different methods for solving the same question. One, a conventional method, maybe we can have a look at it. What we can say that the initial quantity of milk and water, let's take it as 3x and this one is x. We are adding only water, we are not adding milk. So the new scenario, the water being added is 14. But what is the quantity of milk being added? Nothing, 0. So I'm adding 0 here. What is the new ratio? 2 by 3. So basically this ratio, 3x by x plus 14. Now this ratio is 2 by 3. So one equation, we have an unknown x and we can get the answer for that. So multiply, cross multiply, we get this 9x is equal to 2x plus 28. So x is equal to 4 straight away. But then since we are looking at the total quantity, 3x plus x 4x, which is 16 liters, is the total quantity. This is what is method number 1. But we want to get ourselves acquainted with all the possible approaches which are being involved here. Method number 1, and which is this. Now let's move ahead with this method number 2. In method number 2, we apply what we can have a look at is this concept, allegation. Now, in this allegation principle, we would like to, now here we are talking about for any one parameter we are looking at. If it is concentration, it has to be concentration all throughout. But then if you are taking, let's say, milk concentration, it has to be milk concentration. Here it also has to be milk concentration. So we have to stick to it throughout. If it is water concentration, then this has to be water concentration. This also has to be water concentration. And what do we keep here? Total quantity, total quantity. That means if I implement this idea, now what is the milk concentration? I don't say that 3 by 1 into 100. Impossible. That's not what the milk concentration is. Milk concentration is milk by total. Milk by total. Now what is total here? If it is 3 parts and 1 part, the total is 4 parts. Total is 4 parts. So it becomes 3 by 4, and which is nothing but 75%. So we say that, okay, let's have 75%, which is the milk concentration. Now, to this particular mixture, to this particular solution, I'm adding water. Now, in water, when we say water is added, essentially we are saying that in water, there is not even a single drop of milk. So, if there is not even a single drop of milk, what is the concentration of milk there? 0%. Nothing, 0. So, we say that, okay, this solution is mixed with a milk solution with 0% concentration. Now, when these two are mixed, what do we get? We get a new ratio. New ratio for what? Milk by water. Now, milk by water is what? 2 by 3. So, what is milk by total? Because we are interested in milk concentration. So, milk by total is becoming 2 by 5. And 2 by 5 is how much? 40%. So, this is kept as 40% here. But then, what is it that we are interested in? We are interested in the total ratio. This part, total. But now we know that what was added over here? 40 liters of water. So, even if this milk quantity is 0, we'll not put this as 0 here. That doesn't make sense. What we are interested in, what is the total we have taken? The total we have taken is 40. So, above this line, we are writing the total. Below this line, we are talking about the concentration. Let it be 0, let it be 100, doesn't really matter. Now, thereafter, the difference is what we shall be dealing with. 75 and 40. How much difference? 35. We write this difference, which is 35. And further, the number here is 40. And then the last part. This ratio is 8:7. This is T:40. So we can say that T by 40 is 8/7. And hence the total quantity which is obtained here becomes 16 liters. So that's the whole scenario as what within this method number 2 is. The idea is whether a method is slow or fast, that's a different question altogether. What we are looking at is, can I solve this question by different approaches? So this is what is method number 2. Moving on to method number 3 is the same rule of allegation, but a small change here. In this small change, what we shall do, if you observe carefully, everywhere, all throughout, we have taken milk concentration. That's what we were dealing with. Now, can I take all, let's say, water concentration? And if we do take this as all these numbers as water concentration, do we have to make a change here? No. My T or this 14 remains as it is. So, entire thing under this line, you have to stick to one thing, right? Milk concentration or maybe water concentration. So, in this method number 3, we'll see that if I take numbers which are related to, let's say, water concentration. Then what happens? Do we get the same result? We'll see that. Water concentration, now this is 3 by 1. Water is 1 part, milk is 3 parts, total is 4 parts, 1 on 4 is 25%. So corresponding to this is 25%. So we're dealing with water concentration. Now what is water concentration here? 40 liters of water. It's only water. That means water concentration is 100%. The mixture here, the solution here is giving me milk by water in the ratio of 2 by 3. And 3 parts of water, 2 parts of milk, 3 by 5, which makes it as 60%. So this number is kept as 60%. Now we are interested in the difference. 160, the difference is 40. This difference we get as 35. So my intermediate steps were slightly different here, but my final ratio is never going to change. 40 is to 35 is back to 8 is to 7. So 8 is to 7, T by 40. That's what we saw earlier on, 8 by 7. And hence we get the total value which is equal to 16 liters yet again. While this was method number 3 and method number 2 both were more or less the same, in fact the interesting part is, do we have some other approaches also? Yes. Within this allegation principle we can apply some other method also. Now what is that other method? Let's have a quick look at that as well. Because the understanding of different approaches will give us a comprehensive view, and that's what is the objective behind what we are taking up as all these approaches here. The next one, let's say maybe the method number 4. What we are saying that if we have this 3 by 1, can I proceed with this 3 by 1 in itself? Do I have to make any change here? Well, the milk by water ratio is 3 by 1. Milk by water ratio, final which is obtained, is 2 by 3. And but what is milk by water ratio here? That doesn't make sense. Like we have only milk which is 0. So we can proceed with this. So that means I draw a line here. Everywhere I'm going to write down this as milk by water. That means whatever number is there, I don't have to convert that in terms of percentages. Milk percentages or maybe let's say water percentages. We'll simply write this as milk by water. Now how much is milk by water? 3 by 1. How much is milk by water? Well, milk is 0. So this is straight away 0. How much is milk by water? Finally 2 by 3. So we'll subtract this. Now when we subtract, what do we get? 3 minus 2 by 3. So that turns out to be 7 by 3. This way we have subtracted. So clearly we'll subtract that, and pretty much straightforward here, 2 by 3. Comes the interesting part. Now, friends, what is it that we will be writing here? Is it the total quantity here? No. That is the most significant and the critical element here. The key thumb rule is whatever comes in the denominator, when we are taking up the fraction or maybe the percentages data here, whatever comes in the denominator, that is what is kept above this line. That means if I am keeping water here, look at this. This is water here. So we can see that water quantity will come here, water quantity will come here. Now, water quantity we don't know, we'll take care of it. The water quantity we know that. Now, what is the water quantity? Because everything is water. So water quantity is how much? 40. So comes the last point here. We see that, look, water quantity in the first, that initial solution, water quantity divided by 40 liters of water, which is anyway, that's what the complete content is, which is 40 liters of water. This ratio is 2 by 3 is to 7 by 3. That makes it as 2 by 7. So water quantity, that becomes 4 liter. But then we were getting the total quantity as 16 liters. Yes, both are same. There is no difference. So what we just now got that water quantity is 1 part, milk is 3 parts. So if water quantity is 4 liters, the milk quantity will turn out to be how much? 12 liters. So 4, 12, that makes it as 16 liters. Back to 16 liters here. The total value will never ever change. Whatever method we really want to apply, method number 1 or 2 or 3 or 4 or any other approach which we might be having for a question which we are dealing in this particular format. But the idea is to get exposure to all the varieties, all the approaches which are possible for any such question. With this, let's move ahead with the other question. Let's look at this question where we'll see that application of that rule of allegation, and all these parameters over here will be kept as or related to Let's friends have a look at this question where the milk water ratio for the two different mixtures they are given. For one, take 4:1, for the other one also 3:1. And the resultant mixture is 77:23 milk water ratio. We need to find out in what ratio the two mixtures have been mixed. Again, that can be taken up in multiple methods. For example, one of the methods we can adopt in solving this question, again within this rule of allegation, you take up, let's say, milk concentration. 4 units is milk, 1 unit is water. 4 units is milk, 1 unit is water, so 4 on 5, which is 80% milk. Similarly, 3 units is milk, 1 unit is water. So that is 75% milk. Now then thereafter, if you take 77 units of milk, 23 units of water, that makes it as 100 units of solution. So 77% is the milk concentration. We'll take the difference here, which is 3. This difference is 2. Everything is in all percentage terms. We take the ratio. So we can say that the ratio will turn out to be 2:3. As for the ratio of in what quantity we have mixed the first mixture as well as the second mixture. While this is the first approach here, we can have a look at it from the multiple approaches as what we saw the earlier question as well. So in the other approach, we can take up, let's say, maybe the water concentration. And taking water concentration, we have to stick everywhere with that water concentration. So in the first one, 4 parts is milk, 1 part is water. So 1 on 5, which makes it as 20%. This one is 1 on 4, which makes it as 25%. And this one is 23%. The difference is 3%. And similarly, this difference is 2%. So my final ratio will remain unchanged, which is 2:3. So that's what is the second approach, where we have taken up everything which is related to water concentration. We can have a look at it from the third angle, and which is this. Instead of converting everything in terms of, let's say, percentages, what we can do, we can stick with this ratio. Let's call it as 4/1. This one is 3/1. And let's say this is 77/23. The only thing we got to be careful, please note that this is all milk by water. Now my denominator is water here. So what what we have to keep it here is the quantity of water which is there in the first mixture. Similarly, the quantity of water which is there in the second mixture. So once you obtain this difference and final ratio, you will be getting the ratio of how much water is there in the first mixture and how much water is there in the second mixture. So now you take the difference. Now you say that this is 23 times 1, 23, 23 times 4, which is 92. 92 minus 70, 77, which makes it as 15/23 as the difference. Similarly, this difference, the same way, 69, 77 minus 69, that makes it as 8/23. So that means the ratio what we get is 8:15. Now, this is not the total ratio here. The water content is, if it is 8 parts, the water content over here will be 15 parts. Now please note that if the water content is 1 part, the total is turning out to be equal to 5 parts. So if the water content is maybe, let's say, 1 part, we can say that the total will be 40. So this is 40 parts over here. In the same way, if you look at 15, if this is 1 part, my total will be 4 parts. My total will be 4. But my actual water content is how much? 15. So 1 part is 4. 15 parts will be 60. So the ratio is 40/60 is total ratio. That comes back to again 2/3. So again, this is the different method here, but just we got to be careful what exactly we have to put it here. And that is governed in general as a thumb rule by what is there in my denominator. So that's what we have multiple approaches in answering this question, or what we have as a last approach, we can avoid all this allegation principle and we can adopt our conventional method in terms of arriving at the answer. And in that conventional method, we can say that, look, for this milk and water, I have for this mixture number 1, let's say that this is 4x is the quantity of milk, x is the quantity of water. Now in the second mixture, let's say that this is 3y and this one is y. That's the quantity of milk here, the quantity of water here. So 3y and this y, it's a different ratio. Now in the final resultant scenario, I have 4x plus 3y and this one is x plus y. This ratio is given, which is 77/23. So in this method, we are just simply trying to adopt it using a ratio concept. And using this ratio concept, cross multiplication will further give us the answer. We'll complete that as well, which is 92x plus 69y. This is 77x plus 77y. In fact, all of these approaches are more or less very similar. It's just that the presentation aspect which makes it a bit different. So 15x is equal to 8y. So we can say that my x by y will turn out to be 8 by 15. Now once we get this number, which is 8 by 15, please note that this is not the ratio of the total quantity here or the total quantity here. Look at it, the total quantity is 5x, 4x and x. Total quantity is 5x. So we are interested in 5x by 4y. Now x by y is 8 by 15. So from here we can say 5 by 4 into 8 by 15. That turns out to be back to 2 by 3. So this is a standard ratio method which we have applied, and we have seen that the same problem like being done in almost 4-5 different methods over here. And yes, everyone, yes, you have to be very thorough with all the ideas which are involved in solving any question, be it maybe averages, mixtures and allegation or maybe any other subtopic.